All right, so welcome everyone to our math school. As you know, this is I was going to say a regular school event that takes place that is made possible by the National Institute for Theoretical and Computational Sciences, NITheCS. And in particular, it is an initiative of the Mathematical Structures and Modeling Research Group at NITheCS. So last week, if you had joined us, the math school was hosted by myself and PhD scholar Shimon Korkus, who is based at the University of KwaZulu-Natal. And this week, as you can tell, today I'm joined by Michaela Hunselaar, who is actually also going to be a PhD scholar pretty soon as she registers to take on her PhD studies. Hi, Michaela, how are you doing today?
Well, thank you, and yourself.
I'm doing well. Yes. So, Michaela, maybe before we continue, you can tell the students more about what it is that you did this year. We can keep it very brief. Just tell them about which university you're based at, what studies you engaged with, and maybe we can use a moment to inspire everyone who's watching you.
Okay. Yes. Hi, everyone. I am based in Joburg, so I live in Joburg, have studied in Joburg for most of my life. I've just finished my master's. I submitted at the end of June. And at the moment, I'm tutoring for the University of Johannesburg. So lots of maths. I'm very passionate about maths, and in particular, lots of algebra. So I encourage you, if you enjoy algebra, to stick to it and enjoy it as much as you want. And yeah, I think that's the idea, is to just enjoy it.
So what Michaela has not told you is that she completed her undergraduate degree. So for those of you who are now planning out your studies post-school, so she completed her Bachelor of Science degree. Isn't that so, Michaela, majoring in?
In pure and applied mathematics. So maths and then applying mathematics into real-world situations as well. Yes.
Right, and then she completed her honors, yeah?
Yes, I also did honors just in pure maths, so I decided I'd rather stick to the pure maths side of things and stay in academia and teaching. And yeah, completed my honors in 2021, and then for the past 18 months I've been doing my master's.
Okay, so for those of you who are now thinking post-school, so remember the first step to your tertiary studies is your bachelor's degree. Following that, you then enter into an honors program. And if you complete your honors program and you want to continue, then you proceed to complete a master's degree, specializing in the discipline that you will choose, followed thereafter by a PhD, a doctorate. And that's the path that Michaela has chosen. That's also the path that I had chosen. Okay, but nonetheless, that was just a quick background on Michaela, so that you also know about, just learning about what are the steps one should take in their study journey. So I just want to quickly check our chat box. Wonderful. We had lots of comments coming through about who the students are and where they're based. So today, Michaela and I decided that we would like to talk about functions, right? So, I mean, functions is something you learn from as early as, I think, grade 8 or perhaps before. Is that the case, Michaela?
I think grade 8 you start with straight lines, and then if I remember correctly, grade 9 you sort of do some of the sort of very early hyperbolas, parabolas, and then you go more in depth as you go on with, yeah, I suppose your more complicated parabolas, and then finally in matric you do cubics.
Indeed. Right, so we all start off by learning about straight lines and how straight lines can be described. Right, so what is a function? A function is a mapping, isn't that so? Right, so it is a mapping from some set into another set, and it sends elements from this set, right? So if I had to pick an element from A, if I picked an X that lives in it, then my function f would map it to some element that lives in B, okay? And it would map it to the f of X. So it's like a machine. You pick a value from the domain, right? So this set A is the domain of the function. You pick a value from it, you plug it into the machine, which is f, and you get out an output, right? And that output lives in the codomain, right? So that was just a quick crash course of the behavior. I didn't really say much about it, but a function is a mapping from one set into another set, okay? All right, so straight lines in particular, how can one describe that? So of course, when we work with straight lines, we typically work from the set of reals into the set of reals. So we map a real number to a real number, right? Meaning that geometrically, I am able to draw that straight line on the axes, on the XY axes, on the XY plane, sorry, right? So that's what we're looking for. So now those of you who are joining us live, can you remember how one describes the function of a straight line? So this is from grade 8. And Michaela, you can help us out by checking the responses. Let's check. Okay.
So we have someone saying y equals mx plus c.
Wonderful. So now we need to understand what that means, right? So I'm writing it down as fx equals to mx plus c. Right, and what was that? Okay, I see more responses coming through. Tendo, thanks for your response there. So this m, as you say, is the gradient of the function. And the c is the y-intercept.
Akira says the y-intercept, yes.
Okay, wonderful. In particular, if the m was positive, it means the line rises. If the m was negative, it means the line falls. And if the m is equal to 0, what happens? Do we know? Nothing yet. Michaela, what happens when gradient is 0?
So when your gradient is 0, it means your function is not changing, it's not growing, it's not decreasing. So you have just a horizontal line somewhere on your plane.
So it's flat, basically, right? So yeah, there's no rise, there's no fall, it's constant. So this is typically of the form y equals to some value, right? So if I had to draw something, so this would have been a y equals mx plus c, right? So this would have been your f of x equals, let's just say, okay, I'll let it pass through there. Let's just say x plus 1/3, right? So that's a line that rises, that intercepts the y-axis at the value 1/3, right? And of course, you'd be able to draw various types of straight lines based on how the equation is provided to you or how the function is described, right? So I'm not spending time on straight lines today. Let's move on. What are other types of functions? Michaela's mentioned quite a few, right? So as you continued with your studies through school, so you progress from grade 8, you move to grade 9. What else would you have encountered? Parabolas, right? So Michaela mentioned parabolas. So right, so the other type is parabolas. And typically this function here, this function, if I wrote it down in terms of the independent variable x, right? So this would have been written in the form, okay, I'm going to describe everything, but I hope this is now going to look familiar to you. Does that look familiar at all? Wonderful, yes. Okay, lots of responses coming through again, Michaela. Let's check. So what does the A represent? Do we know? So in general, the most basic form of a parabola is y equals to x squared.
Ntando says A represents the shape.
Excellent. So when A is positive, we end up with a happy face. When A is negative, we end up with a sad face. So that coefficient in front of the bracket squared actually tells us about what type of graph do I get. Do I have something that opens upwards? Or do I have something that opens downwards in a sad face kind of way, right? So yeah, when I say happy face, sad face, I'm referring to the smile, right? That's what I'm referring to. Okay. And then we've got a few other things happening. In particular, I've got this x minus p, and then I've got this plus q. What is that actually helping us do? What is that doing? To me, it looks like somebody is asking me to translate my graph, right? Okay, and there are responses coming in. So what's happening in there, Michaela? Do we have something
Yes,
about P and Q?
Marco Sonke says we are determining the turning points when we look at the P and Q, or the turning point rather. Yes.
So that is a turning point on this basic graph x squared, right? Good. No, I didn't spell that right. And so that's a turning point. In particular here, it's the coordinate 0, 0, right? It's opening upwards because in here, what is the a in y equals to x squared? Okay, I see Tendo also gives a response. So what did Tendo say? Let's take a look.
So Tendo said it's the horizontal and vertical translation from the origin.
Wonderful.
So very nice way.
Because, yeah, that's an excellent way of thinking about it. And so if we come back to y equals to x squared, this is the most basic form of the graph. And now if I start affecting x by minus p, then that is a translation of the x coordinate from y equals to x squared by p units to the left or the right. What do you think?
So that would be p units to the right, in the positive direction.
Good. So this is p units to the right. And what is happening with the q if I think about it in terms of translations again, as Tendo had suggested?
So q would be, I'm just waiting. Yeah, so Tatum says q shifts us up or down.
Okay, so this would be if q, whatever q was, if q is positive, of course, then I'd just say q units up. If q is negative, I'd go q units down. Right, similarly, the type of value for p determines whether I go to the right or whether I go to the left. So maybe I am now going to say right or left, but of course you have to use your discretion. The minus in front indicates you go to the right. And if we had a positive net value, right, then we would go to the left when it comes to P. So here, if Q is positive, then we go Q units up. And if Q is negative, we go Q units down. Right, so that's the idea. Okay, there is a question. What does our question say?
So Amahle says, why is it that if it's x minus p, then we shift to the right, but if we have x plus p, then we shift to the left?
Good point. Very good point. Right, so in here, this is us thinking of x minus p equals to 0. Right, so what we're doing is we're trying to solve for that turning point. Okay, and so in here, this implies to us that x equals to p. And so that p value is the x coordinate for the turning point. Right, so when it comes to translations with respect to x, we end up moving in opposite to what the sign indicates, right? Because this is in the input of the function, it is affecting the input. But when it comes to affecting the y value, this q is now affecting y, right? So when you add a positive value into the function, it affects the output, right? So you would move Q units up if it was positive. Or if I decided, you know what, I'm going to subtract 3 every time, then it would shift the Y value down by 3 units each time, right? So essentially, that is what is happening. So I'm going to talk about translations very quickly. I will summarize them. But here, I just want to mention that this description for the parabola is a very generic one, okay? So one thing that you do need to know is that the turning point is given by PQ. Once it is in this form, you can read off the turning point. And that is why the turning point here for the function y equals to x squared is 0, 0, because it's clear that P is 0 and Q is 0 in that function, right? So what happens usually is you are not given the parabola in that form, as you see above. It is not given in that way. It is typically written in general form. And that general form is y equals to ax squared plus bx plus c. And then it is your job in the upcoming tests and exams to then take this quadratic expression and convert it. So you're going to have to take that and convert it to look like that. Do you all remember how to do so? Michaela, did we learn any techniques on how to take something of this form and write it down in a factorized form like?
We would need to complete the square.
Okay, so we are going to complete the square. Okay, maybe let's do a practice run very quickly. So example, let's say I give you y equals to x squared plus, okay, let's say 6x minus 15. Okay, so this is going to be a parabola, but I would like to write it in that factorized form above, where there is an x minus p squared plus a q in particular, so that I can read out what are the turning points immediately, right? So how does one go about doing that? Well, we need to focus on the coefficient of the x, right? And what we do is, so this is off the form. So what we need to do is in step 1, we need to compute b over 2. And in step 2, we must subtract b over 2 squared, right? So we do this by writing it down as follows. So it's x, and this is a plus in here. So I preserve that. So now I'm just teaching you a method, right? Right, so it's going to be plus b over 2 minus b over 2 squared minus whatever I had in here, okay? So I'll just write down minus 15. So, sorry, adding whatever was above there, and that was minus 15. So that's what's happening. And so this becomes x plus what? What value goes in there? What's b over 2? 3, right? Good. Squared. And then b over 2 squared, that's 3 squared. So that's 9 minus 15. And of course, you can then simplify that, right? So you can then write that down as minus 24 if you wanted to. And that would now tell you what your P and your Q is, because you'd be able to write, read it off. But now, is this actually true? I mean, is this here? This must be equal to this because I've got equality signs there, and you can check it. So let's check. Do we get back what we've written down? What is x plus 3 all squared? It is x squared plus 6x plus 9. So that's what this is. Would you agree? And then it's minus 9 minus 15. So do I now get back line 1? Do you see that you do get back line 1? Wonderful. Right, so So that is precisely what completing the squared does. It takes your quadratic expression and it rewrites it. It allows you to rewrite it in an equivalent form, where the form now looks like that. And here you'd be able to read off what the PQ is. The P is -3 and the Q is -24. Is that correct, Michaela?
Yes. Yes.
Okay. Right. So are there any questions pertaining to that? Okay, so there isn't. So what I've done is I've basically recapped on parabolas. I also wanted to recap on, let's see, I want to do a bit
Tendo,
on...
please go ahead and ask your question. You're more than welcome to type it into the chat. So why is the P, P-Way asks, why is the P -3?
Good question. Because this is of the form x minus p squared plus q. So therefore, this implies p is -3. And q is read off as you see it, right? Which is -24. Yes, you equate that to 0 and you'd be able to solve that it's -3. Okay. So the next thing I wanted to quickly recap on, and I'm going to spend probably 3 minutes on this, and then I'm going to hand over to Michaela, right? I wanted to talk to you about hyperbolas. Right, so this is typically of the form y equals to k divided by, again, your x minus p plus q. Right, so that's your general form. And here again, the k usually tells you something about how this hyperbola is going to look. So if we had k was positive, then that indicates to you that the picture of the hyperbola you will work with is in the first and the third quadrant. And if k was negative, then it indicates to you that you're going to be working with the second and the fourth quadrant. All right. And once again, these here, this x minus p and this q, this is helping you determine your axes of, your vertical asymptotes and your horizontal asymptotes. So here you've got x minus p equals to 0, implying that x equals to p, and that is a vertical asymptote. And then you have y equals to q, which is a horizontal asymptote. Okay, so Michaela, just for safety's sake, this is where I am now going to hand over to you, and I will be a backup because of my load shedding that's going to kick in shortly.
Cool. All right, let me get my screen sharing on then. All right, can I just check, can everyone see what I'm sharing? So you should see a screen that says question 9. Let me pull up the chat. Yes, okay, fantastic, thank you. All right, so what I'm going to be doing with you guys now is some practice questions based on functions from last year's final. So just to sort of get an idea of what's going on and the types of questions that you can expect and how you should approach answering them. Okay. All right, so this question in particular, it's question 9. We're given that f of x is equal to x squared, so a standard parabola, which we spoke about earlier as well. And we are then asked to determine the minimum distance between the point 10, 2 and a point on f. So I've just drawn it for us to get going. This is our f of x equal to x squared. And then we have the point 10, 2. Let me just zoom in for us. So we have a point 10, 2 sitting somewhere over here. Right, and then just to illustrate what we're trying to do, we can anywhere on, so from this point, draw a line to anywhere on our parabola. So we could go to this side, we could come here, And we can see that all of these lines have different lengths, or they're varying lengths. So there's various distances between the point 10, 2 and our parabola. And so in particular, we want to max or to minimize this, or to optimize it, and find the minimum distance between this point and our parabola. So how would we go about doing that? Well, let's first decide what is the distance between 10, 2 and a point. So let's pick a point. We'll put it over here. So if this is our point x, y, then we can look at the distance formula between, or the distance between these 2 points. Can anyone maybe suggest there's maybe something better to include for this y over here? So if we know that our function is x squared, what can we include for this y? We can make this y x squared. So we know that the coordinates of any point on this parabola are going to be x and x squared, because the y value is actually just x squared. In that case, so we're now looking for this distance over here in the blue. And I'm going to, so I think it'll be a bit strange to ask you to type the distance formula in the chat box. So let me give you the distance formula. So the distance formula is going to be d is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Yes.
Yeah, that's correct.
Okay. Yes. All right. So now we have 2 points. We have our point in terms of x, but that still means it's a point. We can sub it in. So let's sub in for this particular case. So we know that d is going to be the square root of x minus, so we'll take, this is our point 1 and this is our point 2. So we'll take x minus 10 all squared plus x squared, so that's our y. I'm sorry, I've done this the wrong way around. So this should be 0.2 and this should be 0.1. X squared minus 2 all squared. And we need the square root of that. So to make lives easier for ourselves, let's simplify at this stage. We'll end up with, from this bracket over here, when we simplify, we'll get x squared minus 20x plus 100. And from the second bracket, we'll get x to the power 4 minus 4x squared plus 4. All right, and then one last step in terms of simplifying, we need to say that this is x to the power 4. We have an x squared and a minus 4x squared. That leaves us with minus 3x squared. And then we have minus 20x plus 104. Right, so this is actually the function or the expression that we want to optimize or to minimize. So we want to be able to minimize d.
So we did have a question that says, what if you didn't know you should make y into x squared? Well, if I can just respond there, Michaela, but you can add on if I miss anything out. So, well, you could have left the y in there and you could have still written out the formula from the distance formula, follow the steps that Michaela had provided. But then you would have observed that you had a function in terms of x and y, a function of 2 variables, which is going to be very difficult to work with. And then when you looked at that, you would have realized, oh, well, I can write down y equals, well, you would have been able to write down y in terms of x. And so that's how you would replace all of the y's with x squared. And that's how you end up with what Michaela's written down now, which is simply a function of x.
Yes, yeah, I think that's good. Then someone says, to minimize, do we have to apply the derivative? So is this related to calculus? Yes, that's exactly what we're going to be doing in the next step, or in a few steps time. All right, so we want to be able to minimize d. As Tendo says, that sort of gives us an idea that we might want to be using a derivative. But if we look at this function, we suddenly have a square root. And although, as far as I'm aware, you guys can tackle finding the derivative of a square root function, I mean, I might get into trouble for saying this, but as mathematicians, we like to be a bit lazy. So if there's a shorter way to do it, that's what we would like to be able to do in this case. And what we're going to do here is we have the distance function, which involves a square root. But what we know about a square root is that this distance function d, so let me grab, I'll copy paste it. So d is at a minimum when the function without the square root is at a minimum. So when the following is at a minimum, when d squared equal to that is at a minimum. And so what we can do is we can minimize this function, and that's just we can derive that quite nicely using the power rule, and we can then solve from there. All right, are there any questions at this stage?
No, looks good so far.
Okay, all right, so let's get going. All right, so what we need to do, so we're going to, so we will minimize d squared. Wait, yes, minimize, right? Okay, and how do we minimize d squared? Does anybody have a suggestion what we're going to do here?
Equating the derivative to 0, that's a response that's come through.
Yes, so that's what we're going to be taking. We want to take the derivative of this d squared function, and then we're going to equate it to 0. So let us take this derivative. Okay, then one of the rules that we have when deriving is something known as the power rule. So the power rule tells us that the derivative of x to the n, so some power of x, is going to be, we bring this exponent down, put it in front as a coefficient, and then we leave x as it is, and we subtract 1 from our exponent. So this is our power rule. There's a question from Denzel. Since everything was squared in those brackets, why didn't we cancel the square roots? So not everything, so remember, we can't do the following. So if we have, the following rule does not hold in mathematics. So the square root of a squared plus b squared is not equal to a plus b. Okay, so two numbers that you can use to compare this would be if you have a equal to 4 and b equal to 9. Sorry, let's rather not go that way. But yeah, so just be careful. We can't go ahead and cancel these squares if everything is squared. We have to first simplify underneath the root before we can take that square root. Okay, all right. So let us apply the power rule and continue. We want to find the derivative of x to the 4. According to our power rule, we bring down this exponent of 4 and we leave x alone and we subtract 1 from the exponent. So we'll get 4 minus 1, which is 3. And then we now need to subtract. We would bring this exponent down, so bring a 2 down, but we'd multiply it with this 3 now. So here we'd be left with 6x, okay? And then we have minus 20, and this x will derive, when we take the derivative of x, we end up with just 1. Maybe another rule to consider here is the derivative of a constant. So the derivative ddx of any number c is going to be 0. So the derivative of a constant is just 0. So what is the derivative? If we think a derivative is a rate of change, how fast is our function changing? A constant doesn't change, and so the derivative of a constant is going to be 0. So when we take the derivative of 104, we don't actually include it, or it's going to be 0, so we don't do anything there. Right, now we want to equate our derivative to 0, so we want to take 4x cubed minus 6x minus 20 and equate that to 0. And now we sort of move into our cubic functions realm of things. We want to be able to factorize this cubic in order to figure out where this particular cubic is 0. So does anybody have any suggestions? What is our first step when we want to factorize this cubic? Okay, common factor 2. All right. So we can take out a common factor, definitely. Okay, so we left with 2x squared minus 3x minus 10 equal to 0. Okay.
And Marshall also suggested using a calculator.
Using a calculator. We can use a calculator, but for now we're going to do it by hand. By all means, you are allowed to use a calculator, but the calculator won't show you all the steps, and steps give you marks. So please make sure that you are showing as much as you need to show when you are answering the question. All right, so what we would need to do now is we would need to find one factor. We need to substitute in factors. Usually what we like to do is substitute in factors of this 10 over here and see if we can find a factor, something that makes this expression over here 0. So in particular, you would try plus or minus 1 as a first guess. Then maybe you'd try plus or minus 2, and you'd realize that if x is equal to 2, then we end up with the following. So 3 times 2 minus 10.
We do have a response in the chat about an error with the exponent. So I think you just wanted to write down cubed.
Sorry, over here, cubed. Yes. Thank you. Yes, 2x cubed. Thank you very much. Why does, yeah, so sorry, guys, Bongani, thank you very much. That was an error that we've now corrected. So this should be a 2x cubed. All right, so now let's see what happens here. 2 cubed is 8, and then 2 times 2 would be 16. Then we want to subtract 6 and subtract 10, and we end up with 0. So we now know that x equal to 2 makes this entire expression 0, and so x minus 2 is a factor. Okay, and obviously the reason that we chose this one and it was the right one first time round is because I'd done this question beforehand. So in general, what you want to do is you want to choose factors of 10 in this case from over here, or factors of 2 from over there. Okay. So someone says they've missed the last 10 minutes. Will they be able to access a recording? I believe they will. It will be posted onto YouTube, I believe, Dr. Rathilal?
Yes. Yes,
yeah.
On the NITheCS YouTube page.
All right, so now let us continue. So if we know that x minus 2 is a factor, then what we can say is the following. We can say that 4x cubed minus 6x minus 20 is going to be equal to x minus 2 times some other bracket over here. Okay, sorry, no, we need to get rid of these. So these changed as we were moving downwards. All right, so sorry, 2x cubed minus 3x minus 10 is equal to something. What I'm going to do is I'm going to use inspection, because I believe inspection is sort of maybe the newest and the most daunting of the methods that you have. You also have synthetic division, the algebraic long division. So please use whatever method is most useful to you, but we will use inspection in this case. So what do? We know that this expression in this bracket over here is going to be some kind of quadratic. So I like to first put in an x squared and an x to remind myself of that. Then what we do is, for this first entry in the bracket, we look at what multiplication is going to give us this x cubed. So which of the multiplications, if we try to FOIL out or distribute out these brackets, would give us 2x cubed. And that would have to be only the first term in the first bracket times the first term in the second bracket. So x times x squared, or something x squared rather. We're looking for what is this something at the moment. And in particular, we notice that we need to end up with 2x cubed. And so this over here needs to be 2x squared. So that when we take x times 2x squared, we get 2x cubed. Then for the next part of our bracket, we look at this minus 10 and which of these multiplications would give us a constant, or the multiplications that we're doing when we distribute. And that would have to be the two constants times one another. So this minus 2 times whatever the constant is that we're going to put into this bracket. So if we look, we have a minus 2, which means we're going to need a positive 5 in the second bracket in order to get to a negative 10. Right. Then the magic happens when we put a plus k. So we put in a placeholder for now, and we're going to solve for that place for that k next. To solve for that k, we have a look at what is what we have on our left-hand side. We have this minus 3x. So we look, okay, which of our multiplications would give us an x to the power 1? So that would have to be the x in the first bracket times the constant 5 in the second bracket, and this minus 2 times the k. Right, so if we do that, we get that, we call it equate coefficients. So we can say, well, minus 3x needs to be equal to 5x minus 2kx when we do that multiplication. So that's where those two terms have come from. What we can now do is we can call out an x and cancel. So we get minus 3x is equal to 5 minus 2kx. The x's would cancel. We now know that minus 3 is going to be equal to 5 times minus 2k. All right. We can then solve. We know that we'd get minus 8 on the left-hand side and minus 2k on the right-hand side, which then tells us that k must be equal to 4. So at this stage, we can now, whoops, not like that. Come back up here. I'll make it this small on this side. And we can say, well, then 2x cubed minus 3x minus 10 is going to be equal to x minus 2, 2x squared plus 4x plus 5. All right, and we remember what are we doing here? Well, we're trying to take all of this and equate it to 0. Okay, the next step here would be to see if we could factorize this expression. Okay, and so sort of factors of 2 and 5 that make up 4. What you'll see when you try to do that is there are no factors. So in particular, rather than using equals, we can use implies. We could, yes, if you wanted to say an implication, you could use an implication. All right. Where was I? Yes, so if you try to factorize this, you might run into a bit of a hurdle there, and that is because we can't actually factorize this. So we could use the quadratic formula. We could, yes. Let's just, as a hunch, check whether or not we could potentially find roots there. So let's see what delta is in this case. Delta is going to be b squared minus 4ac. Okay, what do we end up with here? We end up with 16 minus 4 times 2 times 5. Here we'd end up with 16 minus 4 times 2 is 8, times 5 would be 40. So we end up with negative 36 underneath the, or delta is going to be negative 36. What does that tell me about what are implies? So implications are, it's something that we cover in the first year of mathematics, and I think maybe a little bit in, negative 26 in applied maths, AP maths. So please don't worry too much if you don't know what an implication is, you don't have to worry about that at all. All right, so here, what do we know? What would delta equal to negative 26 tell us? What does that imply for us? 24. Thank you. 16 squared. Oh, goodness. Okay, wait. Sorry. So this should have been 4 over here, and then there should be a squared there. So what I've done is I've jumped ahead and then gone a step backwards at the same time. Okay, so then non-real roots. That's the answer I'm looking for. So what does this tell us? This tells us that this expression, 2x squared plus 4x plus 5 equal to 0, has no real roots. So no solution in that case. So what do we know now? We know that x can be equal to 2, or we have no real root. So the only solution to this derivative being 0 would be x equals 2. Are there any questions at this stage?
I think it was explained really well.
Yeah. All right. So what have we done now? We found that the only solution.
Delta.
Yeah.
Okay. Somebody just needs to know your delta, Michaela. It's just a label,
Delta,
everyone.
Delta is this expression. This is delta. So delta, it's a letter in the Greek alphabet. If you don't know where that comes from, so your quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Delta is this expression over here. Okay, and it tells us it's the nature of the roots, right? So that's where that comes from. Okay.
Right, so the delta is the discriminant, right? And based on what values we have for the delta, if the delta is positive, if the delta is negative, if the delta equals to 0, it will determine how many solutions the quadratic formula has. Right?
Okay, so yeah. Let's quickly maybe go through that. I think we have a bit of time. So if we know that if delta is less than 0, then we have non-real roots or imaginary roots. Okay, if delta is equal to 0, then we know we have equal roots. If delta is a perfect square, yeah, then we have rational roots. Okay, and then if delta is positive, but not a perfect square, then we have irrational roots. Okay, and I think that covers everything. Am I missing anything?
No, perfect, Michaela.
Okay, all right. So we now know the only solution to our derivative equal to 0 is going to be x equals 2. And this would be where our distance is at a minimum. So we now know that this is where d squared is at a minimum if x equals 2. That tells us that d is also at a minimum if x equals 2. Okay, but what did the question actually ask us? So it asked us to find the minimum distance. So we now know where it is. We know what x value it is at, but we need to actually find that minimum distance. And to find that minimum distance, we would need to substitute into this distance formula. So let us grab that. I think we might have some unwelcome guests as well. So let's get rid of those. All right, so we now need to substitute x equal to 2 into our distance formula. So d is going to be the square root of 2 to the power of 4 minus 3 times 2 squared minus 20 times 2 plus 104. Okay, that ends up being the square root of 68, which is the same as 2 root 17, which is the same as 8,25 units. Right. So that would be how we would approach and answer this question.
Sure.
Does anybody have any queries?
So I don't see any questions right now in the chat box. We have around 6 minutes, but maybe we could take 10 minutes to answer one more question.
Okay. So I think we could possibly start on the next question I had planned. I don't think we'll finish, so maybe we'll get through at least 8.1 and some of 8.2.1. And we can
So Tendo has requested if we could just quickly go through the explanation for changing between d and d squared.
Okay, so the reason we use d squared and not d, the distance formula we know always has square root, right? And when we try to take a derivative, which we usually do when we want to minimize, derivatives involving square roots tend to become quite complicated. And so what we would rather do is we'd rather see if we can get rid of that square root in some way and work without the square root and bring it back later. And that is actually what we do. So what we do is we consider the distance squared. So we square this whole expression and we end up, so we take this and we square it, and then we get d squared. And in this case, the absolute value is going to fall away. And the reason we can do that is because when d is at a minimum or a maximum, then d squared is also going to be at a minimum or a maximum. So we can consider only this d squared and or sort of translate it back into d later on. Does that explain it a bit more?
Yes.
Yes,
We've got
at
half.
the same time.
Yeah, absolutely.
Okay, perfect. All right, so let's see how far we can get with this next question. This next question is also from last year's final. It's question 8. So we are given a graph y equal to f prime of x. So maybe this would set up alarm bells for you. Here we have the derivative of f. Okay, so the derivative of some function f is equal to mx squared plus nx plus k. So what does that tell us? Well, that tells us we have some kind of parabola. Okay, one of the things I would suggest, just in terms of when you are writing an exam, sometimes there's information given at the top that's not given in your diagram. So please make sure that you go through all the information that you're given in your little paragraph, your preamble, whatever it is, and make sure to include it on your diagram. So we have a parabola, well, that's shown on our diagram. We're told that the graph passes through these 3 points, -1/3 and 0, 0 and 1, and 1 and 0. So that's all included. And we sort of are noticing a derivative, but we're not really too worried about it yet. Okay, so what is the first question here? First question we're asked is to determine the values of m, n, and k. So that is m, n, and k over here. We want to basically determine the equation of this parabola. At this stage, again, if you're sort of a bit freaked out by the derivative maybe, don't worry about it. So what are we asked to do? Just focus on what we're asked to do at this stage. We're asked to find m, n, and k. What are m, n, and k? M, n, and k are coefficients coefficients and constants in a parabola. So we can go ahead and find those quite easily. All right, so what are we given in this parabola? We're given 2 turning points, and we are given a y-intercept. Okay, can anybody maybe suggest which of the, how do we go about finding the equation of this parabola? Which of the forms do we want to be using? Turning points. Okay, so we could find, so when I was first preparing for this question, that was also what I thought. At a first glance, we would be able to find the x coordinate of our turning point over here. What we don't know is we don't know the y coordinate of this turning point yet. So that isn't necessarily the easiest step at this stage. It would work. It might take a bit more sort of hand grinding to get through it. But at this very stage, the easiest is to use the dual intercept and point method that we have. All right, so what do we have? Well, we know, let's just call it y for now to not start to involve that f prime. So y is equal to, we want to use the dual intercept method. So we have a x minus x1 x minus x2. Okay, that means we have, let's substitute in these two intercepts. We have x, when we substitute, let's do it in the two steps. So minus 1/3 and x minus 1. Okay, see, I'm running out of time, so I'll go quickly over here. All right, or yeah, as quick as we can. So we end up, when we simplify here, we get x plus 1/3, x minus 1. All right, now what we can do is we can substitute in this remaining point that we have. Okay, and you can do it before multiplying out. It does make your life a little bit easier. So we substitute in the point r. We have 1 is equal to a times 0 plus 1/3 minus 1. This means that 1 is equal to minus 1/3a. So this just becomes positive 1/3 times -1 times a. We then get that a is equal to -1/3. So that tells us that y is equal to -1/3 plus x, times x plus 1/3, x minus 1. And then our last step here would be to multiply it out and simplify. So we get -1/3.
So, Michaela, we've got 1
Yes.
equals to 1/3 a. So you'd be dividing
Yes.
both sides by 1/3, right?
Sorry, yes.
Yeah.
This becomes -3. Apologies, yes. There we go. Okay, a is equal to -3. All right,
Wonderful.
then we could, so next step is to multiply out. We get x squared plus 1/3x minus x minus 1/3. Right, and that would leave us with -3 x squared plus 2/3 minus 1/3. Is that correct? 1/3 minus 1. So that would be minus 2/3. Okay, and then we end up with, so we can now distribute this -3 in. We end up with -3x squared plus 2 plus 1 plus 2x plus 1. All right. So what does that tell us? That means that m is equal to -3, n is equal to 2, and k is equal to 1.
So let's check. Are there any questions pertaining to this part?
I make these questions seem so easy. So I did spend a bit of time preparing, so I knew exactly what was coming for me, which, I mean, in your final you don't, and you've probably had very little sleep. So what I would recommend is to practice as much as you can, because the more you've seen, the more you will see the patterns that pick up as you go along in your test. And then also to make sure that your mind is at its strongest, make sure that you are well rested and ready to go.
That's good advice. All right, so everyone, thank you for joining us. This recording does typically end up on the NITheCS YouTube page. I'll just quickly type it up in the chat box so you'll know where to find it. Let me just type this to everyone. Right, so it's the National Institute for Theoretical and Computational Sciences. So NITheCS. But let's take a moment to quickly thank Michaela for doing this online. This was her first time doing this session, and I think she did brilliantly. So thank you to Michaela for setting aside time, for coming and joining us for this live session. Thank you to all of the students who have joined us today. There will be a follow-up session next week, Friday. And joining me next week, Friday, we have a master's student from UKZN, Kavir Sumaraj, who will be joining us. So I hope to see you all there. And once again, thank you for joining, and thank you to Michaela.
Thank you very much for having me, and enjoy your weekend, everyone.